Hello students, this video is about proving triangles congruent. So let's go ahead. The idea of congruence, we've already learned that two geometric figures are congruent if they are exactly the same shape and size. So the question is, how much do you need to know about two triangles to prove that they are actually congruent? Well, yesterday in class we learned that in order for them to be congruent, that means that all 6 pairs of corresponding parts are congruent. So all the sides are congruent and all the angles are congruent. However, you do not need all 6. Instead of knowing all 6 sides are equal and corresponding, you can just use these 4: side, 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 angle, side, angle, or angle, angle, side. So first let's look at side, side, side. Here we have the purple triangle marked, and you can see that the one side, AB, is equal to the side DE, and the side BC with 2 is equal to the side EF, and AC is equal to DF. So all 3 sides are marked congruent. This is a congruence statement, all right? And it says triangle ABC is congruent to triangle DEF. Now, next we have side, angle, side. So for side, angle, side, we can see that we've got side AB equal to DE and side AC equal to side DF. And then we have the angle that's in between those two sides. So where those two sides touch, that is called the included angle. And that part is important, recognizing which one is the included angle. For side, angle, side, that angle must be in between the two sides. So let's see if we can recognize which one would be the included angle in this example. In this first triangle, I see that this side is marked GI and the side is marked GH. Well, the included angle then would be what? GI or H? It would be G, because that's where these two sides touch. Okay. In the next picture, the included angle is where this side GI touches the side HI, which is up here at the top at I. And the included angle for this one would be where the side IH touches GH over here at H. So that is what it means to be the included angle. Now, you can also tell the included angle because the included angle is represented in both lines. This line YE has an E in it, and this line ES has an E in it. So the included side between YE and ES, well, they both touch at E. All right, and now that you see that pattern, you can easily see that these two both have an S in it. ES and YS both touch at S. The included angle is S. And for the last one, between YS and YE, the included angle there is Y. Okay, so the next congruence theorem is angle, side, angle. And in this one, in the picture here, you can see that angle A has been marked congruent to angle D, and side AB has been marked equal to side DE, and angle B has been marked equal to angle E. So the important part here is that the side between the side, angle, side has to be the side connecting, the side that's included between the two angles. So, we need to make sure that we have the included side. So what would the included side be for this first triangle here? Well, it's the side that connects to angle G to angle I. So the side that touches both G and I is GI. And the side that connects the H to the I, the included side here would be IH, or HI. And the included side between G and H would be GH. Okay. And we can tell the same thing just from the letters themselves. Here we have angle Y and angle E. The included side between them would be YE. And the included side between E and S would be ES right here. And between S and Y, the included side down here connecting S and Y would be SY. So the next congruent statement is angle side. The difference between this one and the previous one is now we have two angles, but the side is not between the two angles. We have angle, and then we have a side on the outside. So look at that, how that looks on these triangles. A marked equal to D, B marked equal to E, and then BC marked equal to EF. So we have a non-included side. So you might have noticed one of the ones that's missing is there's no SSA postulate. And I like to say that by saying there is no backwards donkeys. All right, we cannot have this postulate. And actually, tomorrow in class, we're going to discover why, see why that particular postulate doesn't work physically. You can't make congruent triangles with that. So if you see something like this and you read the pieces in order, I see angle A is marked, then I see side AB, and then this side BC. Well, if the angle was between the two sides, it would be okay. If angle B was marked, it would be fine because it would be side, angle, side. But as it stands, the angle comes first, angle, then the side, then the other angle. So these two triangles are actually not congruent by our statements. Also, there is no angle, angle, angle postulate. Now the reason that there's no angle, angle, angle postulate is because you could have a smaller triangle like ABC here and have another triangle that has equal angles but that is a little bit larger. So you can see that triangle DEF is actually bigger than ABC, even though they have the same angles. So having the same angles does not create congruent triangles. So here we have all of our congruence postulates: side, 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 angle, side, angle, side, angle, side, angle, angle, side, and we cannot have side, side, angle, okay, and no angle, angle, angle. So which postulate do you think, by which postulate do you think these two triangles are congruent? Okay, so what you're going to do is you're going to look at one of the triangles and you're going to read the markings in the order that they appear in. So we're going to follow along connecting them. So first I see a side marked right here. Then that side is touching an angle here. And then that angle's coming to another side over here. So I have so I have side, angle, side. And does that match on the other triangle? On the other triangle I have again a side, an angle, and a side. So these two triangles are congruent by the postulate side, angle, side. Okay. Read these in order. Now, if I start at, you can start whichever corner you want. Let's say I start in this corner. Here I have an angle that's marked. Okay, touching that angle, I have a side, and then I see on this side I have another angle marked. So read the markings in the order that they go. I see an angle, then a side, and then another angle. Now, could you read this in the other way? Could you start, oops, where's my mouse? Could you start over here and say, okay, angle, and travel this way around the triangle? Well, no, that doesn't work because there's nothing marked over here. So you have to go in the order of where the markings are. So you don't want to come that way. You want to come from this angle to the side that's marked and then to the other angle. So, and does that match on this one? I see an angle, okay. Because I started on the one that had 2 marks up here, I'm going to start on the one that has 2 marks on this triangle. Angle, then a side, then another angle. So this is angle, side, angle. Okay, which one would this be? Let's see. I see an angle marked here. Then I'm coming to a side, and next to connecting that side I see another side. So I see angle, side, side. Okay, so if I were to write that out, A, S, S for angle, side, side, I've got a donkey here. We do not have any backwards donkeys. We can read it the other way as well as going by side, side, angle. So this one is not allowed. We have no backwards donkeys. And actually you can put these in either order. What markings do we have in this triangle? I see a side and another side, and actually all three sides are marked. So I see a side and a side and a side. So this one is side, side, side. Oops, I'm sorry. Yes, we do not have any of those. Okay, and this next one is side, side, side. Okay. Alright, and in this first picture I can see that I have all three angles marked. That means that this one is angle, angle, angle. Are we allowed to have angle, angle, angle? No, that's not one of our postulates. In the next one I see an angle, a side, and another angle. Okay, so this one would be angle, side, angle. And down here I see side, angle, side. Side, angle, side. Okay, how about on this one? This one would be a side that has the two dashes, and then I see another side that has one dash, and then an angle here, angle. Or on the other triangle I could have an angle, and then a side, and then another side. So I've got side, side, angle. Am I allowed to have side, side, angle? No, that's not one of our postulates. Okay, one more thing I'd like to point out to you is that sometimes something might not be marked in the picture. In this one, I can see that these two triangles here actually share a side in the middle. When the triangles share a side, that is the reflexive property. So even if that side is not marked, you need to go ahead and mark it in the picture. That's reflexive property. Now that it's marked, now you can see what postulate it would be by saying, okay, this would be a side marked, then an angle, and then on the inside here another side. So this is side, angle, side. Another thing that might not be marked in the picture is when the triangles share an angle. Angles straight across like this, across an X, are called vertical angles, and they are equal. So if they are vertical angles, we need to mark those. Vertical angles are equal, and now I can see that I have again side, and then another angle, and then a side. Alright, here I have vertical angles again, so mark the angle. And now I have side, angle, and then side. And lastly, these two triangles share a side. So that's a reflexive property. Now I have an angle, a side, and an angle. Angle, side, angle is not. Angle, side, side is not one of our properties. We isolate the other way around. Side, side, angle. No backwards donkeys. So that is all for our lesson today, and we will practice recognizing these postulates tomorrow.